And I want to welcome everyone for to join us today. We are thrilled to have back Roberto Pieraccini. Did I say that correctly? And he's going to talk about his latest book, AIAssistants. He has several books, but Plazabridge Group is thrilled to have him join us today. We've got another person joining. And just for those that don't know Plazabridge Group, we do innovation consulting and technology development. We help companies really kind of figure out their new strategies for the future. So a little bit of a futurist organization. But we're thrilled to be able to present trends and information like Roberto can share with us today. So with that, Roberto, I'm going to stop sharing this screen and I'm going to let you take over and share your screen.
Sounds good. Can you see my screen now?
Not yet.
Not yet. Oh, I need to share it again, right? Yeah. Good. Okay.
There we go. It's great. And
you can see my screen now, right? Yeah.
Yeah, we can.
Okay. Good morning, afternoon, or evening to everyone. So it's late afternoon here in Zurich, and really a pleasure to be here. Thank you, Teresa, for finding me again and inviting me to this. All is good. Yeah, I like to talk. As you know, that's why I chose my profession to make machines talk, because I like to talk. So I also ask you to stop me because I can talk too much, right? Sometimes. So this is not a talk about Google. It was more about the general idea of AI assistants that I present on my book. And I'll say a few more words about my book in a minute. About me, for those of you who don't know me, is I've been doing, I've been spending all my professional life, which I don't tell you when it started, so you cannot guess my real age. But it started right after my degree in electrical engineering from the University of Pisa. And I was so lucky to join, among many choices that I had, to choose. The time was a gold time for engineers, especially those coming from Pisa. We had a lot of opportunity to work in technology. I chose to CELT, the Centro Studi e Laboratori delle Comunicazioni, which was one of the jewels of research in Europe, I would say. It was a research lab built as an image of Bell Laboratories. So it has a number of departments and people were quite free to do research at that time. Things changed later. And CELT spun off a company called Loquendo, from which Monica I think used to work, right? I don't know if Monica still works for Loquendo or still works, but I don't know. Then I moved to the United States. I went to Bell Labs, the so-called ivory tower research, and I met the people who were actually the fathers and the mothers of speech recognition, or what today is called speech recognition. And that was actually, the dates are here. You can see the dates. It was late 1980s, and I worked with people I used to read about before. So it was amazing. It was really amazing. Then still the research, not then. I had things in the between, but at some point I worked at IBM, TJ Watson Research for a couple of years. And also I was a director of something called ICSI, the International Computer Science Institute at Berkeley, where I met Miriam, who is one of the attendees here. And there were a lot of research, advanced research fields there. I really enjoyed being there with amazing scientists like Miriam, working in AI, in security, in speech, and so on. I also worked for commercial applications. I worked for SpeechWorks International, which is now Nuance, from 1999 to 2003. I was the CTO of a company called Speech Cycle in Manhattan, in New York, from 2005 to 2011. And we were doing applications for customer care of cable companies, very complex application. trying to do troubleshooting on the telephone, automated troubleshooting, a mix of talking and sending signals to the users, to the customers, cable boxes or modems, and then try to resolve most of the issues that they had. And then the thing that the company is in my heart is Jibo. Jibo was this, and Teresa knows Jibo very well. We worked together at the time. Say it again?
I had a love affair with Jibo. I loved Jibo.
Yeah, we all do. So if I move my camera, you can see a Jibo in the back. Yeah. Hey, Jibo.
That's
It's
awesome.
turn to me, right? That, yeah. So still works, miracles. So it was a consumer robot. We were posed to be the first company to commercialize what we call the social robot, a robot that has animation, empathy, so that unfortunately, for many reasons, and that's could be the topic of another talk. I also given talk of why Jibo failed, and then fortunately, Google found me, and they offered me a position of director for the Google Assistant, where I am since March 2018. Sometimes people say Roberto is the director of Google. No, I'm not the director of Google. I'm not the director of the Google Assistant. Because it's a very large organization with thousands of people. I'm a director for the Google Assistant. So don't give me more responsibility than what I already have. So, let's forget about the honors. One thing that I'm very proud, I got a honorary degree of science from the Heriot Watt University of Edinburgh in December 2019. It came to me as a surprise, and the most difficult thing was to give a speech to was a commencement speech, which is a very terrible thing. I thought about this for 6 months, but I was very happy to go there and receive this honorary degree. So I wrote a book in let me see if I can go next. Yeah, in 2012, published by MIT Press, called The Voice in the Machine. And the book is about the history and the people and the stories around speech recognition, natural language understanding. It's a book of stories more than a book of technology. There's also technology there, but it's building computers to understand speech. It starts from 1780. You know why? Because von Kempelen built a machine that could imitate human speech, and it goes to 1950s where the first speech recognizer, and it comes to, it ends in 2011. And so a lot of things happened from 2011 today, a lot of things. So that's why MIT Press asked me, would you like to write a second book and tell us what happened after 2011? And now we go to the history in a minute. But the book is a smaller book. It's part of what the MIT calls the Essential Knowledge series. I try to be even a higher level than the Voice of Machine. So I believe it's accessible to many readers. You don't have to be an expert of machine learning or speech recognition to read that book. It will be a lot of work, like all books, because when MIT asked me that question, I said yes. I should have said no, and I said yes, and then I started writing the book, and it took me vacations, day, nights, and evenings, and so on. Yeah, but I'm very happy that it came out. So I like to say actually, a friend of my age just retired, and they told I say, oh yeah, remember when we met in the 1980s? And they say, oh yeah, what a long and strange trip it has been. These are the words from a song of the Grateful Dead, the song Tracker, which are beautiful, especially when you reach a certain age, you say, look back and say, oh, what a long and strange trip it has been. It brought me across continents, across companies. So it was a long and strange trip. And I like to talk about history, right? This is the longest strange trip of talking machines. See, it started in 1769 with this guy von Kempelen who built also the Turk, the famous Turk. But he built a machine that actually you can look at it, the original in a museum, at a museum in Munich, when they have it, because it goes around the world. That you can, with the bellows, you push and you create and it makes sounds like vowels or some consonants and so on. But this is just most anecdotal. But you see, it's a long story. And what I call the era of the virtual assistant started in the mid-90s. I won't go through the story, that takes an hour. But it started in the mid-90s when there was a company you see here in the middle called Wildfire that built the first telephone-based system. And it was a intelligent answering machine. It was running on servers, and you could subscribe. You could have a machine, an intelligent answering machine that would answer your calls. You can dial numbers by voice and so on. It was, I remember at the time I saw that, wow, you can do a lot of great things using speech recognition, even if it doesn't work, because honestly, speech recognition at that time sucked, was very bad. But the idea there was, well, there was fire. I said, yes, the technology is not great, but we can put around what we call a nice interface, a nice voice user interface. The term VUI came out at the time, and we can hide the problems of speech recognition. For instance, if you ask very specific questions to the users, they will give you a specific answer. But if you are vague, they can say anything, and the speech recognition will be in trouble. So if I answer, do you want to buy this, yes or no? 95% of the people say just yes and no. And the other 5% say, oh, I don't know what you're talking about. Can you say, but 95% would probably say, answer the question that you asked. So that was the idea behind voice user interface. And then you see other things happen, cloud speech and so on, voice XML. But 2011 is a turning point. It's a turning point because Siri came out. Siri was an application that was built by SRI, the Stanford Research Institute, and Apple acquired it in 2010, and they came out in 2011 with iPhone 4 Plus, something like that. And then after that, you see Alexa, Jibo, Google Assistant, and so on. But let's go to the next slide. Okay, Siri is a tipping point of virtual assistant. So before that, we had virtual agents. So machines, you talk on the phone, you don't want to talk to them, you hate them because you want to talk to a real agent. And generally you call because you have a problem. Yeah? You don't call them because they're happy. You have a problem with your bill, you have a problem with your flight, you have a problem with your luggage, you have a problem with your internet, telephone, and so on. And so you are already in a bad mood. And you call and say, oh, thank you for calling us. Your call is important to us. Stay on the line. And then you have a machine talking to you. And you say, well, I want to talk to an operator. So for many years, I was saying I built a talking machine for people who don't want to talk to these machines. They're terrible, right? They don't want to talk to them. But in order to make them work, because they were a big source of saving for our customers, because a machine costs less than a human responding to the telephone, an agent, we had to make them in a particular way. One of them was system-driven. The machine was always prompting the user, what people call the menus, right? There is a reason, right? Because if you let the user speak, speech recognition could not really understand what people are talking about. Users are captive. They have a problem to solve. Either you decide, okay, forget about the problem, or decide, okay, hang up and call back, and they find the same machine, or maybe they find an operator, they start screaming operator, but generally they are captive. They had to use the machine. And there is a small number of specific goals. So this system go very deep, right? Okay, you have to solve a problem with internet. What type of computer do you have? A Mac or a PC? What type of modem you have? Go deep. What type of problem you have? Can you send email? Can you receive email? Can you go to the web and so on? So, but they go deep in dialogues. There were long dialogues. And there's a clear business model, a clear ROI. That means why we deployed those machines, because customers, like our customers, like Time Warner Cable, Charter Communications, Cox, and so on, they decided that customer care is very, they had to have customer care if they want to be better than the competition, but it's very expensive. So a machine that works well could save a lot of the money. So everything was clear, everything was easy. Even people hated us because they didn't want to talk to it, but everything was clear. And then with Siri, we go into the realm of personal assistants. And personal assistants are user-driven. You're not captive. You have to invoke a personal assistant. You have to call it. You can say, "Hey Siri." You say, you have to call Google. You have to call Alexa, right? No one tell you to do that. And sometimes you can solve the problem in other ways. You don't need that unless you're in a car. The car is a fantastic use case because that's where personal assistant help most. So these personal assistants are generally in an idle state. They're there waiting that you say something, right? The users engage at their will, and no one tells you what to ask. You can ask pretty much anything. So you can imagine the demand that this system make on speech recognition, natural language understanding, so on the technology, because we cannot afford not to understand what you say. So we can punt many times, and we do, but if you want a personal assistant to be effective, you want to understand many ways to ask the same thing. And that's a big problem with natural language interaction. Typically, while the virtual agent interaction are deep, right? A lot of goal, there's one goal. In order to reach this goal, fix my internet, you have to go to 15, 20 questions and tests and ask the user to make tests on the equipment and so on. Typically, the interaction with the personal assistant are very short and very shallow. You can ask what the weather is in Milan, or you can ask to play a song on one of your speakers or devices. You can ask to switch the lights on and off somewhere, and so on. So typically, things end there, except recently, we, and I imagine other personal assistants like Alexa and Siri, start to engage people in conversation, mostly chit-chat conversation. So you can ask things, and this is actually interesting. It's one of the most used applications, especially in countries like in Asia, in India. People ask a lot of questions to the assistant. How old are you? Do you love me? Who made you? Where were you born? And it means people like to talk. So, and they're not forced to talk like individuals. Okay, in this case, they love to talk, and there was the idea of Gbots. So people like to talk to machines for some reason that is still unknown to us, or we know, the desire of social, of being social, even with machines. And that was studied by many scientists. How machines behave like human if they adopt social cues so. And from Siri 2011, which interesting, came out probably a week before Steve Jobs died, I think it was October, November 2011, with the launch of the iPhone 4 Plus. The world of visual assistants started to bloom, right? So in 2014, we saw Amazon Echo. Microsoft Cortana came in 2014. The Google Assistant in 2016. It came in two versions on a speaker called Google Home, and as virtual on a telephone. And you can invoke with a button or asking, calling. I don't call it because I have five machines here that say, okay, Google, they all start answer me. So, but I say, okay, this one machine here started my telephone.
Sorry, I don't understand.
So I cannot say it. I would say okay G from now on. Okay. Samsung Bixby 2017, Apple HomePod. So Apple went out of the telephone and created their own speaker. Echo Show. So assistant started having a display that can complement the voice. Google Smart Display 2018, there were a number of smart display done by different companies until the Google's Nest Hub that has a camera, sees you, you can interact with gestures. When it sees you, you can even put it in a mode that you can talk to it when it recognizes you. It recognizes your facial features, so it knows it's you or your wife or your children. So it's a very, very, very sophisticated machine. It reminds you of things. So you see here, it reminds me of the weather. It knows where I am. It knows what my calendar is and so on. Now, since 2016, this is 2020 data. I don't think we published the data from 2020, from 2021 yet. So you can imagine it's much more than that today, but we haven't published yet. So 500 million of monthly users, plus of that. I can imagine much more than that today. 1 billion and more devices that use the Google Assistant. 90 and more countries where the Google Assistant is commercialized, and 30 or plus languages. So this is a big thing. It's a very complex. The complexity of this is huge. And it is not just for us. I imagine Apple and Amazon, Samsung, they have the same complexity. And we are trying to answer a question. The complexity itself is a question. How do we handle dozens or hundreds of different, what we call verticals, whether news, media, home automation, timers, alarms, reminders, calendar, and so on, dictation, and so on. Translation, you can ask Google to translate between two languages. You know, you can, so, and one thing that we like to say, it's all about AI. Today, this term AI is known by all world, even though not everyone understands what it is. So most of you probably already know what AI is, but let me go a little bit over. That's what my book does. What it is AI, after all. So this is a little history, a brief history of AI. So, and people like to say that AI had a number of winters and summers. I probably went through all these winters when AI was the bad word. So what do you do for work? Oh, I work on AI. Oh, that doesn't work, right? Yeah. So, and in fact, only recently we started to use the term AI again, but it was really in the, I would say, in the 1990s, yeah, something that, you know, a lot of aspiration, a lot of hype, but doesn't work. Talking about summers and winters, AI started in the summer of 1956, where there was a professor who died recently at the Dartmouth University, who invited the most famous people in the world at the time. There were probably 12, 15, not more of them, like Marvin Minsky, Claude Shannon, Simon, and so on. They were to say, let's spend the summer together here at the university and solve the problem of machine intelligence once for all. And of course, they didn't solve, but they put the basis. They put the basis of what was called the rule-based AI or the expert system AI. So the idea was experts like a doctor, an engineer, a economics expert. So they use rules. Let's say trust the rule with interviews and put this rule in a rule-based system. They can solve the problem. People attempted to do that with speech. There are linguists, right, and acousticians and phoneticians and semanticists and so on. Let's take the rules. We thought that the world was simple, was based on rules, and let's put them in a system of inference system. It never worked. Never worked because the rules are there is always something fuzzy about rules, right? Especially if you go into speech, how to recognize that a sound is a stop consonant, is a voice stop consonant. Well, the rules say, well, if the gap between the previous consonant, the previous sound, and this is more than 2.5 milliseconds, and there is a burst of energy that is voiced before, that's probably a D. That fails most of the times because we speak in different, you know, we use different durations, we are different, our voice is different. So the people to put more rules, but then you never end putting rules. So in the 1970s, especially if I talk, but this goes for all field, character recognition, visual object recognition, and any other field of what we call today artificial intelligence, games, and so on. But for speech recognition at IBM, a guy whose name was Fred Jelinek started approaching the problem using statistical methods. Approaching the problem as if it was a transmission problem. We have a source, which is our voice. We have a source of noise, which is all the distortion that we have in this voice, the noise outside. And then we have a receiver, which is the listener. How to optimize that? And they started using a technique of hidden Markov models that worked for many, many years, right? And that was statistical machine learning. If you see, there is a small thing called neural network. It started in the 1980s. And it was something there was a lot of hype around that. But they fell into a winter around the end of the past century because we didn't know how to make them work well. But then what happens around 2012, there was a revival of the neural networks in a different form called deep neural network or deep learning. And then we saw a flurry of evolution of this system. The first one were just simple deep neural networks, and then recurrent network, LSTM, it means long short-term memory networks, transformers, BERT, which is a bidirectional transformer. Until today, we have what we call large language models. And I'll tell a little bit what that is. So if we move ahead, yeah, very quickly, I will not give you a lecture on neural network. Neural network is a very, as opposed to rules are very specific, that if this happens, if then else, right? If this happens, you do that. Or opposed to statistical machine learning that assumes some statistical distribution on the features. But neural networks are quite dumb systems. And there is a large number of neurons, we call artificial neurons, we do very, very simple thing. They do a multiplication for every, in the brain we call them synapses, but I don't want to keep the analogy with the brain. Neural networks are way more simple to what happens in our brain. So, but they take inputs from other neurons, they multiply them for a weight, they go W1, W2, Wn. They sum all the results, they pass them to a linear filter. A non-linear filter means if the sum is less than 0, just flatten to 0. If the sum is more than 1, flatten it to 1. That's a non-linear filter. And the result goes to another artificial neuron. So if you put them in layers, and you have an input that takes the stimuli or the signal from the input problem, and the output that decides this is a letter A or this is a letter B. These are the decisions, right? If it is optical recognition, for instance. You have a neural network. How many of them you should put there? And that depends on the computers you have. And I can imagine 1980s, we couldn't put many of those computational systems together. Also, we didn't know that putting more, you see, there are input neurons, output neurons, and there are what we call hidden layers. The hidden neurons take input from the previous layer, and they go input to output layer. The first layer takes inputs from the input layer. The last layer of hidden layer sends output to the final output layer. We use only one hidden layer because we didn't know how to put more, because for some mathematical things, there is a problem called the disappearing gradient and so on. So we didn't really know how to do. So in 2012, a professor of Toronto who now works at Google, his name is Jeffrey Hinton, started to understand how to use multiple layers, and the world changed. And when I say many, and that became a deep neural network. A deep neural network is a neural network that instead of having just a single hidden layer, has many, many layers. Now, if you understand how to train them, you can do pretty much anything you want there. You can practically map inputs to outputs. but the input could be any signal you want. Could be words, could be pixels for an image, and the output could be objects. This is a glass, this is a bottle, or this is a smiling person, a frowning person, and so on, right? So, and that depends on how many layers you have and how many neurons you have together, right? And when you talk about deep neural network, we don't talk about millions of layers. We talk about 15, 20, 30 layers. It's already very complicated, but we can do really magic things. Why this is magic? Why neural networks change in a dramatic way the way we do things today? One reason that they are not parametric. So I told you before, statistical machine learning make assumption. I think the one that designs a statistical classifier say, I think this phenomenon is a Bayesian distribution, a multivariate Bayesian distribution. So I create a Bayesian model or Gaussian model, and I calculate the variance and the means, and then these are my classifier. Generally, all the assumptions we make are wrong, right? We say that assumptions are the mothers of all screw-ups, right? You know, so we make assumptions that are never, there is no such a thing like Gaussian in the real life. Something that approximates a Gaussian, but it's not. So they have a limit of performance, the accuracy, for instance. That is the limit of the assumptions we made, right? So you can push more data, you can make the model bigger with more parameters, but the performance don't improve. While magically, we found that deep learning, it's something that approximates a free lunch. The more data you put, the more neurons you put, and the better performance you have. And we haven't found the limit of that yet. That's why the world changed dramatically by using, and this has been applied since 2012. I think the first application was speech recognition, applied to character recognition, to object recognition. When you go to Google Photos and you say, you can do that, search people hugging. You find people hugging. No one tagged that you are hugging your children or you're hugging your partner. No one tagged that in the photos. That's done with neural networks. Or you say, find me, myself, a dinner with friends. You find pictures of dinner with friends because those things were learned by tagging a large number of data, which is called the training data, and then generating classifiers using neural networks and so on. So the larger the model, the more data, the better the result. So size does matter in this case. And you see, I took this from this magazine, syncmedium.com. It's all data, May 2020. And it refers to OpenAI, which is a research company of Tesla. And they developed something called GPT-3. You probably heard about that. And you see, now you can characterize these networks by the number of parameters. How many of these weights? I told you about weight, multiplying weights I had. 1,000, 1,000,000, 10 million. See the first networks, if you see at the beginning of region, they had 10, they had, you don't see that, but the accuracy was small percentage. Now you increase from to the hundreds, to the thousand, to the billions of parameters. Can you imagine what billion parameters need to be trained? All this, a billion of these weights that need to be trained with a process called backpropagation. We found that the performance are amazing. So I was talking about how virtual assistant works, and I think I went over the different technologies, automatic speech recognition that transform, and I made examples before, so I just connected to what I said before. The dialogue manager is the orchestrator, natural language generation, speech generation. I made an example. So I have only one slide left here. So now we have been building this type of things using the technology, the machine learning technology that was available to us even before deep learning came to be. And what is happening with deep learning, every one of these modules, is slowly being transformed into a deep learning machine, deep learning module. So what is the future? What is the future? And the future that we see, which is very far from here, I don't know when, but as I said, we think that a big, maybe very big deep network, maybe we don't know what it's going to be like 4 or 5 years from now, could substitute all the systems that are there. So this will become something big, right? That we call end-to-end assistant. Maybe it's going to be a large language model, maybe going to be something else, because the progress is relentless. But the idea is to put everything together into a single thing that will look more like a brain. We will, but you know, it's not a good thing to make comparison between brains and machines, right? Because it doesn't hold. The brain is way more sophisticated, and we still don't understand how it works.
Yeah.
So this is pretty much the end of my presentation. And do you have questions?
Yeah, I do, and I think there were some that were coming in as you were talking earlier. I think the first one is, you know, what would you tell people that, especially those that were on the call with us, how they can prepare for the future, taking this technology kind of in their hands? I mean, what do they need to be thinking about in their jobs or for their companies?
Yeah, I think, of course, knowledge is the first thing. Try to understand more deeply, pun is not intended, but how this system works at a high level. You know, there are a lot of books and articles that you can read, people can read at a high. Try to understand that, go to seminars like this and other seminars. So this is the most important thing, right? And then partner with a company that can actually help them to navigate, you know. So of course, Google is a big company, and you know, we interface with third parties, but we're not the only one, right? So there are smaller companies that actually do things, and they can build applications or help build applications for external customers.
Right.
So that's my suggestion. Yeah.
Well, I mean, do you also have a sense for what how it might affect the workforce of the future, in terms of you know, the roles and what should, you know, I know education's a big deal, so you're prepared to go in, but how might this affect the workforce?
I think that you know, the progress is always scary, right, for workforce, right? But we don't know. Actually, we're always afraid. Oh, something, you know, train came out after horses, and we had way more opportunities, right? You know, of work, right? So every new technology creates actually more opportunities of work. And I think it's maybe we need to the workforce need to be able to convert, right? You know, so into the new technology. That's what I said before. Education is an important thing. I mean, companies like Google provide a lot of education, provide a lot of classes, they provide a lot of software that people can use outside Google to learn that, right? So one thing that we are seeing in the technology, we are going more from building things to providing data to build things. So data is the big thing.
Right.
So learning more about data, it's gonna, you know, if you look at this big network that I put there, right, it's gonna be the end-to-end assistant of the future. The way to make it work is to provide a lot of data. We talk about millions or billions of documents of things that need to be used for. So learning how to handle data, learning how to handle big things. So that's the thing that the workforce should start looking into.
And has it moved from, I know, you know, you used to have to think about structured data versus unstructured data. Does it matter anymore how that data is organized?
It does. So machine learning is not magic, at least not magic yet. We don't know if we're going to be able to. So machine learning works what we call supervised learning. And
Right.
supervised learning means that you have to provide data which is in a way annotated or tagged, right?
Yeah.
You know, I had to provide examples. So if I want to recognize horses from chickens, images, I had to buy a lot of pictures of horses, a lot of pictures of chickens, and say, this is a horse, this is a chicken, this is a horse. That's a supervision, right?
Right.
And so it's not, and we are far from human intelligence. Human intelligence, you show one horse and a chicken to a child. Just one example is enough, and we can recognize the horse from far, from close, from 3/4, from front, from the left, and so on, right? So now we need still a lot of data, right? And there is something called unsupervised learning. So imagine my favorite example, which I have in the book. Imagine you are taken and go to a faraway island where you don't speak at all the language of the people living there, right? And then your task is to learn the language, but you cannot speak English. Say, how do you say chicken in your language? You cannot say that. They don't understand you. So you have to use pointing things, and then, but you will learn. The human brain will learn, right? That's called unsupervised, right? So, and the technology is trying to move towards unsupervised, but it's still a little bit, it's not right around the corner, but we're making big steps in that direction.
So what would you tell a CEO, because I've been there with clients before, that, you know, when you're building a conversational, for example, chat application, you basically have a toddler and you're having to help it become an adult by training it on how to talk and what this data really means and how to use that data and say that data to get the answers you want. What would you tell a CEO in terms of planning for new kinds of, you know, using AI and neural networks and even AI assistants to prepare? To prepare the executives and the board level for the length of time potentially, or the cost, or, you know, it's the things that are going to be needed to really make this work.
Yeah, of course, we need bigger and bigger computer, or bigger and bigger pockets to pay computers in the cloud, right? And data is the thing, right? So so I don't think there is a clear way to prepare for the things happening. The future is happening, right? So you have to make a number of steps. You just be aware of what's happening. Have people in your company that understand the technology. And, you know, understand the technology doesn't mean you have to develop these networks. You know, you have to know how to use the software, how to train these things, right? And there are tools to understand the tools, and you know, so and stuff like that. So I think this is my suggestion, right? Yeah. So, and you know, I don't see any other concrete things except education. Understand the environment, understand what's happening.
Are there any specific trends, new things that you see coming out that we all want to hear about that maybe we haven't heard about?
Yeah, we touched on that. So you know, the thing which is interesting, we are moving towards, you know, we had only one device 15 years ago, was a telephone, and the telephone was used to make calls, right? Today we have something we still call a phone, but we don't make calls, right? We text, we go to the web, we use WhatsApp for video calls sometimes, right? Yeah, but and I think this is going to progress, right? We're going to have many other devices. In front of me, I have two computers with big screens. I have one of this Google smart displays, and my TV is an Android TV. So I can actually project my Google photos there. I can connect to it. So, you know, it's interesting. One thing that I joke about, once we have a clear iconographic idea of a telephone, right? We have the things you hold in your hand, the gestures, right? So I call you, right? We're making a gesture like this. There is not such a thing anymore to call, right? Yeah.
That's a good point.
And everything looks like a square.
Yeah.
Why is my telephone different than a TV? It's just smaller.
Yeah.
And why is the telephone different than an iPad? It's just smaller,
Yeah.
but the capabilities are pretty much the same. I can watch movies here.
Yeah.
Like I can make calls here. I can call through the TV. I can use Zoom or thing on my TV, right? Yeah. So
Excellent.
we have only one device, but
Right.
device could be the form factor. Now it's important, right?
Right. Right.
So it's,
Excellent.
yeah.
Excellent. I mean, any closing thoughts you want to share before we go?
The closing thought is I like to say, stay tuned. The future is not what used to be, right?
Yeah.
So
That is
yeah.
such a good point.
Yeah, the future, but it's always been true, right? You know,
Yeah.
I remember I am.
No time like now has it been this true. I mean, it does seem to be exponentially changing.
Exactly. The only difference is it is faster.
Yeah.
It's not, because I remember, you know, I'm probably older than everyone in the audience. And so I remember a time without pocket calculators.
Yeah.
When I was my first year or second year of college, I gave a chemistry exam using a ruler.
Yeah.
I had to do difficult calculation. Then, but I got a pocket calculator, very expensive pocket calculator. I said, "Wow,
Yeah.
it's amazing, right?" Yeah.
Yeah.
But that it took many years to get there. Then what happens at the pocket calculator? We took many years to get a computer and a PC. Now things are happening so fast.
Yeah.
So
Yeah.
that's it's the speed which is different.
Yeah. Yeah. Well, listen, thank you so much for spending so much time with us today. I know we had everyone that signed up on this call. I don't think I've ever had that happen. So
Oh, okay, fantastic,
yeah,
fantastic.
it was
Yeah.
exceptional.